Session 71. SOQL Aggregate Functions. Count, Sum, AVG, Imagine, Max, and Group By. These functions move computation from your Apex code into the database, eliminating the loops, heap consumption, and governor limit exposure that come from querying large record sets and aggregating them in Apex. The reason you want to aggregate in the database rather than in Apex is a matter of efficiency and limits. Apex loops over 50,000 records consume heap and time. A single SOQL aggregate query computes the same result without retrieving any individual rows to Apex. And aggregate queries are exempt from the 50,000 row retrieval limit because they return aggregate result objects, not subject rows. There are 6 aggregate functions. Count with no argument counts total rows. Count with a field name counts rows where that field is non-null. Sum adds up values of a numeric field. AVG returns the average, excluding null rows from both numerator and denominator. Min and max return the minimum and maximum value, and they work not just on numbers, but on date time, and string fields as well. Count with no argument, used without group by, returns a single integer directly in Apex. No aggregate result needed, no get call. You assign it directly to an integer variable. This is the simplest form of an aggregate query, one number, one query. The moment you add group by, you must switch to count of ID, and the query returns aggregate result. All other aggregate queries, anything with a function, group by, or having, return list of aggregate result. Aggregate result is a read-only map-like object. You access its values using the get method with a string key. That key is either the API field name for grouped fields, or the alias you gave the aggregate function in the query. The get method returns object, which you must cast to the appropriate type. Here is a complete aggregate query for revenue by account. Select account ID, sum of amount aliased as total rev, count of ID aliased as deal count, from opportunity, where stage name equals closed one, group by account ID. This returns one aggregate result per account with a one opportunity. The per record querying and Apex arithmetic are gone entirely. Reading aggregate result uses the get method. For the account ID grouping field, call get with the string account ID and cast to ID. For the total rev alias, cast to decimal. For deal count, cast to integer. The types must match what the database returns. Sum and AVG return decimal. Count returns integer. Max of date returns date. If you cast incorrectly, you get a runtime exception, not a compile error. Always alias your aggregate functions. Without an alias, values are accessed via expr0, expr1, and so on, based on the position of the aggregate in the select clause. If you later add a function before an existing one, every subsequent index shifts and your code silently reads the wrong values. With explicit aliases, sum of amount as total rev, your get call is stable regardless of what else changes in the query. One query. That is the point. The aggregate query returns the full summary for every account in your org, every stage combination, every owner, in a single database call. No matter how many opportunity records exist, the query result is one aggregate result per group, and the computation happened entirely in the database. The query limit cost is 1. Group by in SOQL works exactly like SQL group by. Rows with the same value in the grouped field are collapsed into a single aggregate result. Any field in the select that is not part of group by must be an aggregate expression. Selecting a bare field that is not grouped causes a compile error. You can order by using either the grouped field or the aggregate expression itself, and limit restricts the number of result groups. Having is the aggregate filter, where filters individual rows before grouping. Having filters the resulting groups after aggregation. Use having when you want to include only groups that meet an aggregate threshold, for example, accounts with more than 5 closed one opportunities. You can use both where and having in the same query, where filters which rows go into the aggregation, having filters which groups appear in the result. The difference between count empty and count of field name matters in 2 specific ways. First, count empty only works outside group by and returns an integer, not aggregate result. Count of a field name works in group by queries. Second, count empty includes rows where all fields are null in the count. Count of field name excludes rows where that specific field is null. In most trigger patterns, you want count of ID, which counts every row regardless of other field nullability. Min and max extend beyond numbers. Max of created date returns the most recent date in each group. Min of name returns the lexicographically earliest string. When you access date or datetime aggregates from AggregateResult, cast to the appropriate type, date, datetime, or daytime, depending on the field. The distinction between date and datetime matters for the cast. If you cast a datetime result to date, you get a compile error. This example finds the most recent completed task for each account. Select Account ID, max of created date aliased as last activity, from task, where status equals completed, group by account ID. In Apex, cast the result of get last activity to date time, then call .date to get the date portion. This is one query that replaces querying all tasks for all accounts and looping to find the latest one. Here is the complete syntax for group by rollup. Group by rollup with a parenthesis field list produces subtotals at each level of the grouping hierarchy, plus a grand total row. The grand total row has null in all grouping fields. Subtotal rows have null in the fields that were rolled up. You detect them in Apex by checking whether the grouping field value from get is null. Group by rollup produces subtotals hierarchically, one grouping rolled into the next. Group by cube produces subtotals for every possible combination of the grouping fields. Cube is appropriate for cross-tabular reporting where you need row, column, and corner totals simultaneously. Both are counted as one SOQL query. The canonical use of aggregate queries and triggers is the rollup-style parent update. A trigger on a child object needs to compute a summary field on the parent. Instead of querying all children and summing in Apex, you run one aggregate query. Select the parent ID, sum of the field, where parent ID in the set of affected parents, group by parent ID. One query returns all the summaries you need. Map the results, build a parent update list, call one DML. Fully bulkified. Here is the complete trigger pattern. The trigger fires on opportunity after insert, update, and delete. Collect affected account IDs into a set. Run one aggregate query with sum of amount grouped by account ID. Build a map from account ID to revenue. Create account records with only ID and total revenue set. Execute one update DML. This handles 1 or 200 trigger records with the same two governor operations. Common mistakes: forgetting to cast, get returns object, always cast explicitly. Using count empty in a group by query. Compile error, use count of ID. Bear aggregate access via expr0. Use aliases, selecting ungrouped fields in the select clause. Compile error, mismatch cast type for date aggregates. Always check whether the field is date or date time. These all surface at compile time or test time, not in production. That is session 71. The complete aggregate function toolkit. Count, sum, AVG, min, max, group by, having, rollup, cube, aggregate result access, and the trigger rollup pattern. The full article with code examples for each pattern is at realsyllabus.com. Session 72 next. SOQL, Salesforce Object Search Language, cross-object text search in a single query.